We're solving problem 17 from the spring 2021 AMC 12B. Let ABCD be an isosceles triangle having parallel bases AB and CD with AB is greater than CD. Line segments from a point inside ABCD to the vertices divide the trapezoid into 4 triangles whose areas are 2, 3, 4, and 5, starting with the triangle with base CD and moving clockwise as shown in the diagram below. What is the ratio AB to CD? So, for this problem, we first want to just determine these two lengths, AB and CD. Since they're only the relevant ones, we can set respective variables to their sides with their triangle. So, let's say this length AB can be represented as B1 for base 1. Similarly, CD is base 2 for obvious reasons, second base. And then this height dropped down from this triangle to the center is going to be H1, we set it as. So therefore, this height is H2. Well, it then goes that for this problem, we can see that since these are triangles, we can multiply B1 and H1. And since we know their areas, we can equate them to their areas. So, but if you multiply just B1 and H1, we don't want any other numbers here. So instead of dividing by 2 to equate it to 4, we multiply the 2 over to the 4 to get 8. Because this is we want it to set it as a concrete number and not as a fraction equal to a number. And this is possible because since you normally divide by 2 when finding the area of a triangle, you multiply by 2 to find the area of the square when you multiply the area. So base 2, H2 is then equal to, well, this area triangle is 2, so multiply that by 2 is 4. Now we can also get an equation for the total area of the trapezoid. So we know that the total area would be the sum of the bases times the sum of the heights divided by 2. But since you again multiply the 2 over, this becomes 2 times the sum of all the areas here. So 2 plus 3 plus 4 plus 5. Well, 2 plus 3 is 6, 6 plus 4. 2 plus 3 is 5, 5 plus 5 is 10, 10 plus 4 is 14. So this is total area is 28. When we multiply this out, we get B1 H1 plus B2 H2 plus B1 H2 plus B2 H1 is 28. I just wrote it this way so it'd be easier to distinguish what values we know. We already know B1 times H1 and B2 times H2. This is 8 and 4 respectively, so 8 and 4. 8 plus 4 plus B1 H2 plus B2 H1 is 28. This cancels, and then this becomes, well, 28 minus that is just going to be 16. So we then have B1 plus H2 plus B2 times H1. Now for this problem, since we know these values, we can kind of set things equal to each other. Or not things, we can just set values. Let's look at this triangle, this upper triangle with base B2 and height H2. We see that they have these lengths, so it can't be 2 and 2 for the lengths of the triangle, then they would be equal. So the only other integer configuration for B2 times H2 is 4 and 1. So we can then we can say or set we can let H2 be equal to 4, and we let H2 be 4 and B2 is 1. After we assume these values, because it's going to be 4 and 1, this is going to be 4, b1 plus h1 is 16. Now, there's a really important insight over here. What we have here is, well, we have these values in b1 and h1, but we can't really do anything because the only values we know are them multiplied across now. So we see this h1, and we want to get to a value here, which is 8. It's the only value we know. So how do we get from h1 to b1 times h1? We have to multiply by b1. So if we multiply this whole equation by b1, this becomes 4b1 squared plus b1h1 is 8 equals 16b1. Dividing by 4 on all sides, you get b1 squared, and then move the 16 over, which is now minus 4. b1 plus 2 equals 0. We simply solve this quadratic to get that b1 is equal to 2 plus or minus the square root of 8, which is 2 root 2. But since we know that we can't be subtracting a value, in this case square root of 8, that's larger than this value, so that the side length would be negative, we want positive side length, so it has to be the plus option here. So this is 2 root 2. So this is our answer for this problem. Length of b1 is this.